Welcome back, class. This is your Catia mentor, and today we're going to discuss curvature continuity from G0 to G1 to G2 all the way up to G3. We're not going to discuss any continuity further beyond that, so let's get started. So let's start with this cylindrical shape. Okay, so let's first talk about point continuity. If you're talking about curves, we'll use C. If you're talking about surfaces, we'll use G. Okay, so C0 or G0, that's point continuity. Okay, so what does that mean? So if I was to create a second surface connecting to this cylindrical shape, for example, if I was to extrude vertically in the Z direction, we've created a second surface, and right at this edge, that's referred to as G0 surface continuity. At this point, where the arc and the vertical line meet, that's referred to as C0 point continuity. Okay, so as you can see, it's not a smooth transition. If you were to run your hand along this surface, you could feel the change in direction right away. You can feel the sharp edge. Okay, so that's referred to as G0 surface continuity, point continuity. All right, so if we wanted to improve on that, what we can do is come off at a tangent. Okay, so let's go ahead and create, let's use extrapolate, and we'll go off of this edge to create what's called tangent continuity. Okay, so here we have tangent continuity. So tangent continuity is referred to as C1 for curves or G1 for surfaces. So that's tangent continuity. And a good example on this is most likely your desk or a coffee table. On the corners, typically you'll see a flat surface and then a round at the corners, right? And you can pretty much, even though you don't see the line, you can pretty much know where the change starts, right? When you go from a flat, in this case, to a radius, cylindrical shape. Okay, so this edge is referred to as G1, tangent continuity for surfaces. At that point, it's referred to as C1 as you go from the arc to the line. Okay, so C1 tangent continuity. If we want to improve on it, we can go up to curvature continuity. So let's change the continuity to curvature. Okay, so now we have curvature continuity, and now we have a lot smoother transition. So here it would be very difficult to tell where one surface ends and the other one starts. And then we also have G3 or C3 continuity. That's where you have curvature continuity and equal rates. Okay, so I'm going to go back to the very beginning and explain one and each one at a time in detail. So let's go back. Let's go back to this one. So here we have a styled fillet, which was created in a Freestyle app. It was not created in generative wireframe and surface app, but in the Freestyle app. So let's go back to G0, G for surfaces, apply. So as you can see here, we have some type of connection between the blue and the green surface. And this is something that you'll see in aerospace, manufacturing, automotive. Sometimes it's okay to have a sharp edge, right, for machining. Sometimes it's not. So if you want to improve on that, we can go up to G1, right, tangent continuity, and apply. And typically in aerospace and in manufacturing, this is good enough. Right, so we talked about C0, we have a sharp edge as we transition from one surface to another. And now we have tangent continuity. That's pretty straightforward. Now let's go into curvature continuity. So once again, C0 or G0, we have point continuity. We have a connection. And we've increased it now to C1 or G1, tangent continuity, right? So we have a tangent transition from one to the other. So if you want to improve on that, you want a smoother transition, then we go into curvature continuity. Now, where do you see curvature continuity? Typically, aerodynamicists, aerospace, they try and have a nice smooth transition from one surface to another. As you're joining a surface to maybe it could be the nose of the fuselage to the main fuselage body surface, or maybe as you transition from the fuselage to the wing, maybe a wing fairing, a wing to body fairing, for example. So you want a nice smooth transition. You also see this in automotive. So if those of you that work in studio departments where they make the clay models, typically they want at least a C2 curvature continuity or G2. They want a nice smooth transition. It's just a lot more pleasing to the eye. And they refer to this as Class A surfacing in automotive. Okay, so what does it mean? It means we have a connection. So C2 or G2 for surfaces, curvature continuity. In this case, we're showing a connection. Okay, so we have G1, or in this case, curves C0, my mistake, C0 connection. Then we have tangent C1, so it's a transition, tangential transition, and then we have equal radius. So what does that mean? The radii are equal to each other. So what it means is you exit the blue surface or the blue curve and enter the green curve. The radius as you exit one curve equals the radius of the next curve as you enter. Okay, so just to exaggerate, let's say you're going 100 miles per hour and you're transitioning from one freeway to another. You're going 100 miles per hour. Let's make it 100 kilometers an hour. And you transition over to the next freeway or highway, and it also equals 100 kilometers per hour. Okay, so you have equal radii or equal velocity as you go from one curve to another. Okay, so let's go back to our example. So to improve on that, let's go to G2 and 3, 2, 1, don't blink, apply. Okay, so now not only do we have G0, we have a connection, we have G1, we have tangency from one surface to the other, as well as on this one. And finally, we have G2, where the radius of one surface as you exit equals the radius of the next surface as you enter. Okay, so as you're leaving the blue surface at 100 kilometers per hour and you're into the red at 100 kilometers an hour. And then when you exit the red, let's say here on the red you're going 60 kilometers per hour as you exit, it equals 60 kilometers per hour as you enter the next surface. Okay, so that's G2. Now let's step it up to G3. G3 and apply. Hope you didn't blink. Let's go back to G2, apply. Let's go to G3 now. G3 curvature continuity, apply. See the change. So what happened? It was a slight change, but something did happen. So let's go back to our PDF file. So now as you go to C3 for curves, so what happens now is not only do we have C0, we have a connection, and we have C1, we have tangency as we transition from one curve to another. Now we have equal radii, right? So if we're going, and you can also refer to it as velocity. So as you're going 100 kilometers per hour, as you exit, you enter the next curve at 100 kilometers per hour. Okay, what about rate? So now we have equal rates. So what does that mean? So here we're referring to acceleration. Okay, so now the accelerations are also equal as you go from one curve to another. So let's say you're going 80 kilometers per hour, 90, 100. So you're accelerating at 10 kilometers per, you know, 10 seconds. I'm just making this up, right? So as you exit and go into the next curve, not only are the velocities equal at 100 kilometers an hour, but also the rate of change, right? As you're accelerating, maybe you're accelerating up to 110, etc. So the accelerations are equal also as you exit one and enter the other. Okay, and you have a nice, smoother transition. Okay, so that's C3 or G3 continuity. Okay, so now let's analyze this. By the way, there's also G4, and we're not going to get into that. It gets much more complex, but for us, G3 is good enough. Okay, so now let's go drop down to G0, and I'm going to show you Porcupine curvature analysis. And let's turn this around. Okay, so let's look at the Porcupine. Okay, so we have our first surface, the blue one, right? Notice that as you hit a tight corner, you're going to decelerate. So as the Porcupine, I can invert this, but I'm going to leave it alone. As the Porcupine increases, in this case, you're slowing down, you're feeling the G-force, right? And as it flattens, you speed up, right? You can go faster, so the Porcupine drops in height. So you're accelerating and you're going counterclockwise. And here we have an inflection point. So now we're transitioning, going over clockwise, right? So that's the reason the Porcupine flipped. You can actually adjust the Porcupine in the analysis, but we'll just leave it alone for time. So now you're accelerating, and as you're making the turn, you feel the G forces. Here you're going to decelerate. So if you ever worked in again in an automotive studio department where they make the clay models and create the surfaces, they'll refer to this as accelerating or decelerating, right? So you're decelerating, then you start accelerating. Then all of a sudden there's a bad transition, right? Maybe you hit something on the highway, right? All of a sudden there's a drastic transition. Maybe you hit a barrier or something. So that's not good. You're going to get some type of ugly step here or a sudden step on the Porcupine analysis. And as you transition from the red to the green, another sudden jump, right? Maybe you went off the road and went from concrete over to a dirt road. Okay, so let's improve on this. So if we go jump up to G1, tangent continuity, apply. Notice the difference. So now it's a smoother transition as you're driving, right? So as we're turning, going from one surface to the other, there's a step, a drop, and that lets us know, hey, at least we have some improvement. We're up to G1, tangent continuity. But if you want to improve on it, let's go up to G2, curvature continuity. And the velocity as you exit one surface equals the next one as you enter the other surface. Apply. So here we have a connection. Now there's no longer a step. In the Porcupine, we don't have a smooth transition, right? You can see here at this corner. So if we up it to G3, and now the acceleration as you exit one and enter the other are equal, as well as the velocities are equal. So now we have G3 curvature continuity, apply, and we have a lot smoother Porcupine transition, as you can see, for both transitions. Okay, so that's a quick lesson on curvature continuity. Hope you enjoyed it, and see you in the next one.